All right, so we did circles before. When we talked about systems of equations, we just did basic circles. So we're going to do them again so that I can remind you. And then we're going to add to it, just like we did for parabolas. So you have a circle that has your center here at the origin. All coordinates, like x, y, that are solutions to like the equation of the circle would lie on the outside radius of the circle. Right? And so there's a distance formula that tells you the distance from the center to like any point. And so your radius, the easiest one is when you're going from the center to an edge where you can count out how many units are for your radius or down. So a lot of times when we are graphing, we just count like outside and up. We did that little t last time, but the radius would still be the same distance going to any of these other coordinates. So your distance formula in this case is really like x minus 0 squared plus y minus 0 squared. All right, so any radius when you're at like the center here can be used for to find the radius. Depending on where that's shifted, when you do this, like that gives you your standard formula, x squared plus y squared is going to be the radius squared. Because like if I undid that square root and I squared both sides, I'd get the square root of, the r squared is equal to that equation. So you can also use this for any value. So say I have my radius, all right, I can do this with like an x minus h squared, and I can do this instead. All right. So that way I don't have to necessarily have the center at the origin. I can have it anywhere I want. All right. And so that would still tell me the distance if I knew the center and I knew any coordinate on the outside of the circle. It would still tell me the radius. All right. And so we've got two different like general forms for your circle. You've got the first one, which is you've got a radius of r and your center is at 0, 0. And so then your standard form is just going to be x squared plus y squared is the radius squared. So if you have any kind of equation where you don't have a set of parentheses and then the square, then it's just going to be a 0 for that part of the coordinate. All right, but you can also, like I said, you can change that around and you can still have your radius, but you can have your center at hk. Don't write x. It's hk. And so then in that case, that's going to give you a new equation, x minus h squared, y minus k squared still equals r squared. And so based off of this, you can always see what your radius is. And again, like this is going to be just like when we shifted before, it's going to be the opposite of whatever you see when you're looking at these. But when you're trying to figure out the radius or the number of units that you would have to count going outwards to get to the edge, you're going to have to take the square root of that radius. And so like here's just a few. So when you're looking at like number 3, there's no parentheses. So your center is going to be stuck at 0, 0. And that number 9 is something that's already squared. So if I want the radius, I need to take the square root so that my radius is 3. And so the easiest way to do this is to put a dot for your center and then count up vertically and horizontally 3 units on each side of that. Right? And I usually put a point so that way I can have something to like eyeball and run through. Right? And then you can do your best to make a circle that looks like that one up in the corner. Right? It's not going to be perfect, but you want to make it look as close to a circle as you can. And run through those points. So definitely put a dot to identify your center, and then put 4 other dots in like the shape of a T to be able to get the rest of your circle. Right? And so that's just a circle with a radius of 3 centered at the origin. Now the other thing is like ones like number 4, you can't have a coefficient in front. So you have to divide everything by those values. And I'm going to put my equation up here instead. And so I've got x squared plus y squared is equal to 4. And so you need to simplify down your equation so that way it's actually in the general format or the standard format of a circle first. And then you can identify everything. But again, take the square root of that constant, so that way you can get the radius. Again, now you're just going to count 2 on each side. So depending on how big your radius is, depends on how big your circle is. And after a while doing them, you'll get a little bit better at making circles. All right, definitely use pencil when you're making your circles so you can erase if you make like some weird jagged edge. I mean, you don't want it to look like you just like pushed in the side of Play-Doh or something. All right. Yeah, so let me zoom this one in. So now, of course, most of your circles are going to look like number 5. And number 5, when we do completing the square twice, this is what we're going to do, is we're going to create something that looks like this when we complete the square with x's and y's at the same time. So again, now like when you look at your center, it's always the opposite sign of what you see. All right, so my center here is going to be at 1, -2. And my radius is 2. So now this is why it's really important to be able to have that technique of counting outward from your center. Right. So my center is right here at 1, -2. And so when you count up and over, you can see how your circle just now shifted to the right 1 and down 2 from the last one that we just graphed. So the difference between like number 4 and 5 is just a horizontal and a vertical shift. All right, so most of your graphs are going to be like this. They're going to be pretty quick in terms of identifying centers, radius, and then sketching your graphs. There's a couple other little things we want to be able to do with this, though. That's pretty much where we left off, I think, the first semester when we were solving systems, was just being able to do that. And so we've got just a little bit extra, which is what questions 6 and 7 are for. So these ones are about writing equations. And so you want to write an equation where you've got a radius of 2 and centered at the origin. So you're really looking at taking this HK and saying that's the 0, 0. And if they're both 0, then I'm not going to put parentheses in there. But your radius being 2 inches, you have to remember when you're doing your equation that it's the radius squared. So I'm going to have my x squared plus y squared equals 4. And so this is really, number 6 is going backwards to be able to write the equation that was given in number 4, just without the 7 on the outside. Right. So you're always going to be looking at trying to plug into that general formula, either the first standard one where you're centered at 0, or if you've got some other HK. Right. All right, same thing when you're writing the equation with a radius of 5 inches. If you know your radius is 5, when I square that, I'm going to get 25 as my r squared. All right, but this is my h and my k for my center. So if creating the center was the opposite sign, I got to do the same thing when I go backwards. So the opposite of 6 is going to be -6 that I have to square. And then the opposite of -3, when I attach it to my y, is going to be +3 before I square. So finding your center is the opposite, and going backwards is the opposite. All right, so if you have a positive, it'll become negative, and so on. All right, so part of what you're going to need to do is just be able to write some quick equations in terms of knowing the center and the radius, and being sure that you square that radius. Don't just write down 5, otherwise, if you try to take the square root, you won't be able to do that. All right. And then you've got this other fun one. All right, so it's giving you a point 1, 4. All right, so when it gives you the coordinate 1, 4, that's like up in the picture an x and a y. This is some coordinate on the outside of the circle. All right. It's telling you the center is at 0, 0, and that's an h and a k. And you have to find your equation where you have to first find the radius. And so it's asking you for the standard form. And since your center here is at that origin, you're really just looking for an x squared plus y squared equals some sort of r squared. So you're going to want to use that particular formula and use the x and the y that you have to find that piece. All right? Because I don't need to use the parentheses when my origin's at the center. Right? So I'm just going to plug in the x and the y into my equation to find r. So x squared plus y squared equals r squared. Right. So my r squared is 17. Don't take the square root, because what goes on this side of the equation is the r squared. So you're just going to stop at that point. And all you're going to do is rewrite x squared plus y squared equals the r squared you just found. So you're going to use whatever your x, y is and plug it into that formula to figure out your radius squared.